Welcome to MAVE, that stands for Monir's English Version Education. Today we'll discuss on complex number system and the powers, the exponents of I. Do you know what is I? Of course you know. Let's write it on the right hand side of the board. I, that is defined as, I'm taking the white color, that is defined as root over minus 1. So this is the definition of I. Now let's try for I's exponents, positive exponents. So I'm writing here I to the power 0. This is not a positive number. The 0 is not a positive number. This is neither positive nor negative. This is 0. Only 0. Alright? Now I to the power 0 is 1. Because if you put 0 as a power to any base in this universe, you will get only 1. The reason is known to you, of course. Now, I to the power 1 is I. Why is it happening? I to the power 1 is I because if you put the power 1 to any number in this universe, you will get that number even. So that's why this is happening. Now, I square, you know about this? I square. So I means root over minus 1 whole to the power square, because this square is replaced there. This square is even placed there. So this square will cancel out this square root. Then you will have only minus 1. So this is minus 1 and then I cube. So we can split this I cube into two parts. The first part is I square and the second part is I itself. As I am writing I, that means I to the power 1. So if we sum up these two numbers 1 and 2, we'll get this 3, cube. This multiplication is happening as per the rules of exponent systems, which you have studied in class 9 and in class 10. So this I square means minus 1 and this I to the power 1 is I. So we are getting that minus I if we multiply these two numbers together. Now we have 4 different reminders. What is the reminder of? We'll learn a bit later. Okay, now this is 0. So 0 means divisible. What is divisible here in our case? So we'll discuss a few later. Then this is reminder 1, this is reminder 2, and this is reminder 4. Why am I marking all those 4 and no other thing? Let's discuss now. This is I to the power 4. How much we are getting? I square whole square as per the rule of exponent system. So I square is minus 1 and there is a whole square. This square is placed here again. So minus 1 multiplied by minus 1 is how much? Is plus 1. So it is plus 1. You see, there is a rhythm. Memorize this with the rhythm. 1i minus 1 minus I. 1i minus 1 minus I. Why should you memorize this? The reason is here. You see, I to the power 4 is again 1. So it will repeat these all 4 values. It will repeat. If you take I to the power minus 5 and calculate in this way, then you will receive nothing but I, and if you calculate I to the power 6, you will get minus 1. If you calculate here I to the power 7, you will get minus I. So this is the sequence you will be having in future. So what about the previous exponents, the negative exponents, of course, because before 0 you will have negative numbers. So I to the power minus 1, this is even important, in later slides we will discuss. So I to the power minus 1 is 1 over I, you generally call it 1 by I or 1 divided by I, that is it. So I am just multiplying the numerator and the denominator by I. Why am I doing so? You will be understanding now. So first of all, I am multiplying by an I, both the numerator and the denominator. So I into 1 is I into I is I square. Now I square. I square means what? You know, from here I square means minus 1. So you will have minus 1 in the denominator, and in the numerator you will have I. So that is it. I divided by minus 1, that resembles or represents minus I. How come? What the hell is going on here? You see that exponent was minus 1, and removing that exponent we receive minus 1 in front of that I. Wow, what a goal. Okay, let's try. This is even important theorem. You can take it as a theorem. Okay, now the first one is definition, and we have 4 values of i's to the power any exponent. You will receive all those 4 values. You see, before 1 there is minus I, before 1 there is even minus I. So the sequence is intact. Sequence is keeping its own propagation or own progression. Okay, fine. Let's solve this slide now. This is the basic knowledge we are applying to this to solve such problems. Okay, now let's try. So in this case you will just divide this number, this exponent, the positive integer, by 4, and you will have a remainder. So that remainder will be put as an exponent to the I, to that I. So we have to divide this number by what? By 4. By 4. Remind it. So by 4. Mind it. By 4. Okay. But what a big number it is to be divided by 4. It is difficult to divide this number by 4 within a few seconds. In the case, if the number is more than 2 digits, then you have to take the rightmost 2 digits. The rightmost two digits, let me mark it for you. So these 2 digits shall be marked each and every time. Whatever the numbers are given in front of these last 2 digits or rightmost 2 digits are not important to us. So this 89 will be divided by 4 now. Each and every time you will divide last 2 digits by 4. So let's have a rough calculation here. So we'll have 89 and divided by 4 we'll receive 22. Multiplied by 4 is 88, it's nearest to 89, nearest to smallest number to 89. So we are getting 1 as a remainder. What is this called? This is the remainder. So this remainder will be put as a power or as an exponent to I. This is it. This remainder, always. Whatever the number is, whatever the positive number is, take rightmost 2 digits and divide that 2 digits by 4, and you will have a remainder if it is not completely divisible by 4. So that remainder will be put as the exponent of I. So this is your solution. And finally, you will use these special cases. We generally call it corollaries. So this corollary says what? I to the power 1, the second corollary, I to the power 1 equals I. So your answer is I. Do you get my point? Of course, you got my point so far. If it seems to be a bit difficult, so you have to just read or repeat the slide in the case of misunderstanding. To avoid the misunderstanding, you have to repeat the slide. Okay, let's go to the next slide. Oh, there is another power of I, so, or exponent of I. So let's solve. We'll take what? We'll take last two digits. All right, let's have the rough calculation. So now we have to divide this 88 because the last two digits are 88 here. We are dividing this 88 by 4, and we'll receive 88. 4 22s are 88. 4 22s are 88. So the remainder is here 0, of course, you know. So your answer will become like that. I to the power, or I 0 is the exponent to I, and that will become 1. That will become 1 as per the previous slide. So let's go to the next slide. So here is what? Here is another number, and we are ready to divide this 90 by what? By 4. We'll receive 488. Sorry, 422s will be 88. So the remainder is 2. This is remainder, this is divisor, and this is quotient, and this is dividend. Okay, then the remainder is 2. So I 2 means square, I square means minus 1. This is your answer. So within a few seconds even, you can find the answer of the exponents of I. It's very much important for your MCQs and for your university exams. Okay, university admission tests is important. Then let's go to the next slide. I to the power 349039. Then we are having 39, I means 39. We have to divide it by 4. Last two digits, of course. Of course, we have discussed. Okay, did you get my point? Okay, so there's 4. 4 nines is 36. 4 nines 36. So we'll have the remainder as 3. So we have to put here I cube. That means this 3. 3 is called cube in case of exponent system. Okay, then this is minus I. So your problem is solved. Now come to the next slide. What is it? Wow, there is a negative number. Negative number. So we have to, in case of negative numbers, just mind it once that if the last digit or the rightmost digit is, whether it is integer, whether it is odd number or an even number, whether it's an odd number or an even number. I am asking you again, whether it's an odd number or an even number. This is an odd number, odd. If this number, this last digit is an odd number digit, you can easily just put this I in front of that I. Put this negative sign in front of that I. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9. Just I am putting this negative sign in front of that I because the last digit is an odd number. After that, you have to calculate as you have calculated in earlier slides. So we are taking this last two digits, 89, and we know what is the quotient. So we have to divide it by 4, and 4 22s will make 88. Sorry, 88. So the remainder is 1. So we can write I to the power 1, and as per the previous slides, of course. Okay, then it's very simple for you. So it will beget minus I. Okay, let's go to the next slide. This is it. Wow, there is another negative number, but the last digit is an even one. So if the last digit, mind it, if the last digit is an even number, is the last digit is an even number in case of the number being a negative 1. So if the last digit is 8 or any even digit, you just swallow that minus sign, you just vanish it, you just eliminate it, you just remove it or omit it. So you can easily write this one: 1 2 3 4 5 6 7 9 8. So if you calculate a bit faster, it will be more better for you, it will be better for you. Now this is 98. What we are supposed to do, we are supposed to take these last two digits 98 and we're gonna divide this by 4, and how much we are getting there? 4 24s is 96. Okay, so we will have the remainder to be 2. So this 2 will become as the exponent of I. So finally I square is how much? This is minus 1. So this is minus 1. And how was the class? Please comment below my YouTube screen, your YouTube screen. So thank you very much. Thank you for watching.